Learning goal 47, we're going to be taking a look at the area of 3D shapes. We're going to start off with some basic 3D shapes, and we're going to move into somewhat 3D objects. We're going to look at basic 3D objects, and then we're going to take a look at a little bit more complex 3D objects before we move into the next lesson, where it's going to be even more complex 3D objects. But we're going to kind of move step by step into that realm. Now let's just go through a little bit of a reminder here. If we think of the area of a shape, it is the number of squares that fill a two-dimensional space. Okay, so it's the number of squares that fit a two-dimensional space. If we were to put like a 2D rectangle up onto grid paper, we could count all the squares. We could do that with other shapes as well. 3D can't really do that as well. We've been given formulas for many of our normal 2D shapes so that the squares don't have to be counted. Okay, we don't need to necessarily count the squares. We can just take our formulas and we can actually calculate the number of squares that would fit in there. Makes it a lot quicker, makes it a lot simpler, and just as long as we know how to use our formulas, we should be able to do that a lot or quite quickly. A three-dimensional shape doesn't have what we call necessarily an area, has multiple 2D shapes which make up the object. Okay, so you look at this one right here, we have a 3D shape here. Okay, this is in fact a cube. It has 6 squares which make up the cube. Okay, the surface area, and we're going to be very distinct on that difference. Okay, the surface area of a 3D shape is determined by adding all of the 2D shapes together. Okay, so we're going to add all the 2D shapes together. So we're going to take this cube and we would add all 6 sides of it together. Okay, so we have to add all 6 sides together. The first thing that we need to do, okay, when we're doing that, is we need to determine the type of regular shape of each side of the 3D object. Okay, in a cube, in this case right here, we have 6 squares. And so I'm just going to write that down here. We have 6 squares. And in fact, they are all exactly the same size, which actually makes a cube quite straightforward and simple to solve for. The next thing that we do is we solve for the area of each side of the 3D object. Now, if 2 sides are identical, which in the case of this cube, we have actually all 6 sides are identical, okay, we can multiply the answer of one side by 2, or we can think of it as the number of common sides. Didn't quite get that in there. Let's just slide that over a little bit. There we go. Okay, we can think of it as a number of common sides. I know that's not quite as clean and nice as it maybe should be, but it will work for this time here. Okay, so if we do have multiple sides, we can just multiply by the number of common sides. Okay, then what we do is we add all the areas together to find the entire surface area. Okay, so we add all the sides together to find the entire surface area. So in a question like this here, we have 6 squares. Okay, and we can find the area of a square. Okay, area of a square is not overly difficult. Okay, it's just going to be area is equal to length times width. And so to find this area here, we're going to go area is equal to 14 centimeters. And it's going to be squared because it's the same size. Okay, and so the area of one side is 14 times 14. Okay, or 196. Now that's this is one square. Okay, I'm just going to put that in there, which is equal to one square. Not the whole thing. To find the whole thing, we have 6 even squares that go all the way around. And so we're going to take our answer and we're going to multiply it by 6. Okay, so we're going to take it and we're going to multiply it by 6. So we're going to take the 196 centimeters squared and we're going to multiply that by 6. And again, if you want to use a calculator at this point here, it's going to be 1,176 centimeters squared. That would be the entire surface area for this 3D shape, or for this cube, in fact. Okay. Now, that is a regular 3D shape. Again, in this case, all the sides are the same. If we had different sides, we'd have to find each individual side by itself. Now, here's a little bit of a different word here. Okay, a prism. And we're going to be looking at this a lot here. A prism is a 3D object which has a base and top that are the same size and shape. Okay, so in this case right here, we're going to call this the top and not the base. The top and the base are both squares. Okay, they're both the same size, and they're both the same shape. The sides of a prism are all rectangles. Okay, so they're all rectangles. Now, if we know that, okay, if we have a prism, solving for the surface area of a prism is maybe a little bit simpler than actually finding all the sides and adding them together. We can actually do it a little bit quicker, and I'll show you a way of doing that and going through these questions. But first, I want to show you something a little bit different here. Okay, showing all the sides of a prism is a little bit difficult when we look at it, right? There's 3 sides of this prism that we cannot see, that are invisible. But it can be done using what's called the net of an object, okay? The net of an object. This will be done, or this will be what's called, or we would consider unfolding, right there, the prism, so it is flat. In the case of a rectangular prism like this, think of it as taking a cereal box or a cardboard box and unfolding it all so we see it flat, cutting the sides and so we can see it flat. This one right here, what it's going to look like, and I'm going to do a very quick little demonstration of it. I'm going to try to draw rectangles. Okay, so we would have our squares on top, and then what we would have is we would have all of our sides, roughly like that. And I'm going to try to draw them all the same size because that's what they're supposed to be. And I'm going to draw that one there. There we go. And this would be the net of our shape. Okay, that'd be the net of our shape. Now our side lengths, we want to put that in there as well. This is 5 centimeters right there. We can put that up on top. This one here is, or sorry, that is 5 meters. Sorry about that. This side here is 15 meters over there. And then this side right here is also 5 meters. Okay, so that would be labeling all of our sides, at least our measurements. And then we can kind of consider this to be our way of solving for the area. Okay, we can kind of open this up and then we can see exactly what it's going to look like and we can solve for the area. Now, what we have here is something somewhat unique. Okay, this is going to be our top. This is going to be our base. And these pieces right here, I'm just going to shade them in green, are what we would call our lateral area. Okay, it's what we would call our lateral area. Now, our top and our bottom are going to be exactly the same size. They're going to be a square. These rectangles that make up our lateral area are actually one large rectangle that has one side that's given, and the other side, this top side here, is actually the perimeter of our square. Okay, so how we can find our area for this entire entire piece. Okay, so how we're going to find area is it's going to be equal to, sorry, I'm just going to redo this here. Area is equal to 2 times the base area. Okay, so we take our area of our base and multiply it by 2. So in this case, it's a square. And then we're going to add the base perimeter times the length of the object. Okay, times the length of the object. And I'm going to try to squeeze this in as best as possible before your assignment here. Okay, so how we would solve that in an equation is, and I'm going to do it fairly straightforwardly here. We could just add up all the sides. We have 2 squares and 4 rectangles, and that works. But what we can also do is we can say that the area, let's try to get this a little bit better here. Area is equal to 2 times the base area, which is 5 meters squared. And then we're going to add the base perimeter. So that's all the way around the square. That's 20 meters times the length of the object, 15 meters. Okay. And so when we do that, okay, 2 times 5 squared plus 15 times 20 times 15, we're going to get, in this case here, it's going to be 350 meters squared. And that is the entire area. Now we could do that. We could find this is 25, this is 25, and then all of these are going to be, let's see, it'd be 75, 75, 75, 75. Okay, we add them all together, and we're going to get 350 as well. Okay, it's going to give us 350 as well. But we could also do it this way: find the area of the base, which in this case is a square. And so I'm just going to draw that right there. Okay, that's our base area. It's the inside. Okay, and then our base perimeter, okay, is this length right here. Okay, so that length right there, and then we multiply it by the length of the object. Okay, so we find the area of the base, multiply by 2 because there's 2 of them. Then we take the perimeter of that base, okay, the perimeter of that square, we multiply by the length of the object. I'd like you to work on questions 1 through 3. It only deals with rectangular prisms. Okay, these are all just rectangular or square-based prisms, and then we'll move on to other prisms a little bit later.